Hey everyone, thank you all for coming. So today I'm going to be talking about debuggers and hopefully how ETH debug format is going to help, hopefully help you not break your code in the future. So before we begin, let's dig deeper into do we actually need a debugger in the Ethereum ecosystem? So if you take a step back and travel in time to 2016 or 2017, before the first debuggers, what we would actually be capable of doing without it, if in case we wanted to debug our smart contracts, we would basically add print functions into the source code, wait for the compiler to compile it, and then run the transaction and hopefully get some insights into the execution. So basically something like this. Now the funny thing about it is that if you opt in for this way of debugging your smart contracts, you're going to end up consuming so much more time. In fact, we started going to Ethereum hackathons somewhere around that period, and we were extremely frustrated by the time and the energy it took us to find bugs in our contracts. So what it actually resulted in is usually us basically scraping the 90% of the project and going with some MVP version of it. And even a worst case that could occur to you is this one, where your production is down, and the only thing you can do is try to replicate exactly what's going on in the production, and then in that instance add numerous number of prints just to be able to catch where the bug is. But besides this, let's see what are some of the other reasons why we need a comprehensive debugger in the Ethereum ecosystem. So essentially, it's for all the same reasons we need debuggers in the standard programming languages in Web 2. It's just that it's even more amplified in the Ethereum ecosystem. Why? Well, because smart contracts tend to hold a lot of value in them, where you have a program that is basically instructed to do certain things, and if you have a bug in it, if an attacker finds a vulnerability, then all of those funds could be lost. So the most important thing there would be, of course, the security. Then with the rise of the DeFi application and the games in the Ethereum ecosystem, there's also a rise in the complexity, which can be really hard to comprehend if you're a developer who wants to integrate certain protocols. Being able to step through those protocols, analyze that code, can really help you into managing that complexity. And the last part is reliability. Why reliability? Well, of course, when we finish with the development and building of our applications, we want to ship it to the production. In this case, we want to feel confident that once we deploy our application, that it's not going to break automatically. Now, let's see what are some of the frustrations the developer encounter while debugging their smart contracts in the Ethereum ecosystem. So there's the first one, and something that we usually get from our users is that the debugger is not pointing to the right line of the code. How do we actually map the execution environment to the high-level source code is by leveraging something Solidity compiler's outputs that is called source maps. Basically, this array of instructions tell us to which exactly point in the code corresponding execution points. Now, the problem here, of course, is that Solidity, as a compiler, has some bugs, and this is something that we try to prevent by deploying some heuristics, but of course, we cannot always be certain that we're doing the right thing. Next up is the misidentified function calls. So as a standard debugger, we want to have a full function stack so that developers who are debugging their smart contracts can really know in what point in time they're in their execution. How we actually come up with the function stack and how we know where we are actually in the code is by leveraging some of the internals of the compiler into understanding where we exactly are. Now, there are, again, similar to the source maps, there are certain problems there, especially when Solidity compiler utilizes some of the optimizations, as they can basically remove some of the functions from our code. In the cases when we are able to exactly know in which function we are, we can get to a certain problems while decoding parameters. This is simply due to the fact of how Solidity and where Solidity store parameters. Sometimes they are going to be in the Ethereum virtual machine stacks. Sometimes it's going to be in the memory. The other time it's going to be in the call data and whatsoever. So we're not exactly sure where to look for the certain parameters. And on top of that, when we are in a certain function scope, decoding of the local variables can be really cumbersome, again, due to the optimizer, due to some unpredicted behavior of the EVM stack, etc. And there are so many other nuances when you try to build a debugger. Simply put, this is not just a problem for our debugger, this is the problem for any EVM debugger out there. The number and the quality of the data that we get from the compiler is simply not sufficient enough to make a reliable debugger. This is why some year and a half ago, we sat down with the Solidity team. We also sat down with a couple of other tooling companies, a couple of other security analysis firms to try and get together and standardize the way that Solidity compiler is going to output the data that we need in order to make our lives easier so that we can make lives of developers in the Ethereum ecosystem easier. And what we came with is the debugging format that is going to be sufficient enough, that is going to allow us with 100% accuracy to be able to decode and to analyze basically anything in your smart contracts from the low level all the way up to the high level programming language. So what it means in practice is we all know that bytecode on the EVM runs sequentially. This is not the case, so we need some way to map all of those instructions to the high-level programming languages like Solidity or Viper. We need some way to map basically any instructions and to know if it's pointing to a function or if it's pointing to a local variable or some log that is going to be emitted, etc. And we to be certain that we are in that scope of the programming language. And the thing that has also been evolving over the past years is the data complexity of the smart contracts. Developers require from the Solidity team to continue pushing on with the new features, something that some other programming languages in the Web 2.0 space already have. And with this rising complexity, the need for the debugging format is even greater. And the last thing, since there are some custom things to the EVM, as it's not very similar to the traditional virtual machines, we have concepts of gas, we have concepts of 256-bit registry. The need for the format is even greater. Let's see now what are some of the key challenges that the format is trying to address. So the idea, of course, the high-level idea is to help tooling companies build better and more reliable features. So what's the first thing that, and one of the biggest problems that we have right now is the full type definition. Right now, we are mostly relying on some information from the abstract syntax tree that the compiler is providing us with. This is not the most elegant or the best way to consume this information, and the type definition should help us into really dissecting down exactly which type we are dealing with, what's the name of that type, etc. Pointers are also very important. They work together with the type definition. They should help us understand how to decode some specific information from the low-level EVM. So ideally tell us where to look for some information. Is it on stack? Is it on memory? Is it in transient storage? Is it in return data? Is it in code? So I briefly mentioned the source maps, which we currently leverage to map low-level execution instruction to the high-level programming language. Source location should be the evolution of that. They should help us correspond with 100% accuracy, the low-level code all the way to the high-level programming language. And there are even like some of the problems that we encounter right now is during the phase of the optimization of the bytecode, some of those information are simply going to get lost. We're not going to be sure if, for example, we have two similar or very or identical functions. What the optimizer is going to do is simply going to erase one of those functions on the bytecode, and we wouldn't be sure from which location we are coming. And the last point, but this is certainly one of the biggest challenges that the developers are asking, and something that they would really like for a debugger to have is being able to tell you what are all the variables in the scope, and besides that, to be able to understand everything that's on stack. Plus, in a case where some of the variables are optimized out, or we have a constant folded functions, to be able with certainty to say that we cannot find the value of it, or in certain cases be able to reconstruct it with certain functions. Now this format is only in draft version right now, but fortunately Solidity team has already implemented some of the proof of concepts of it. So we were able to get a sneak peek into the information that they're providing us with. And since we have internal tool for the debugging that we constantly test out new features, new functionality, etc., we just couldn't wait for the production version of the format. We had to implement it ourselves. So this is going to be like a quick explanation of how and what the new debugger is going to be capable of having. This is basically the layout of it. This is a simple CLI tool that we've written in Python where we test things out. So on the lower part, you can see the source code. You can see the breakpoint on the line 46. Basically, the new debug format should allow us for the easier implementation of the breakpoints and line-by-line debuggers. On the top left side, you can see the information on the stack. You'll basically be able to see exactly which variables are on the stack. If some variables is not, we would be able to highlight that this information is not present on the stack at this point. And on the top right side, you can see the history of the instructions with all the relevant information there is. Now, I mentioned briefly that one of the bigger challenges that we have is maintaining the function stack, simply because some functions might get optimized out, some heuristic might not work for us. With the new format, we would be able to, with 100% guarantee the function stack. And not just that, be also able to decode all the parameters that are accessible, that is the input of this function. Now, probably not a lot of you know, but since version 0.8, Solidity has released YUL debugging to the general availability. And right now, you can use the YUL to compile your smart contracts. What this is going to do is basically inject some of the Joule functions. So for example, if you're performing an addition of two variables in Solidity, what's going to happen in the background is this function check add is going to be called. And in the versions above 0.8 of the Solidity, if you don't specify unchecked in your function clause, Solidity is going to panic in case the addition of these two parameters overflows. And with the debug format, we're going to be able to basically go down into the specific Yule functions and showcase you what's going on down there. Now, another thing that is also relevant to the Yule debugging is in the next phases of the Solidity, they plan on making the Yule default way of compiling smart contracts. What's that going to allow developers is, of course, much more flexibility. They don't need to worry about having too many variables on stack, etc. But that's also going to mean that most of these variables are not going to be allocated in the stack, which is, again, a good thing for the developers, not a great thing for us, because we need some way of finding those variables. And usually, in most cases, these variables are going to be on the memory. So with the new debug format, we'll be able to fully decompose the whole memory and to have understanding of like each value that's in it. And one of my favorite features of the debugging is being able to watch expressions and variable that is in the scope. We would be able to do this for like any line number anywhere in your code base. And not just it, but we don't need to rely on the compiler to have this information. Right now, we have an implementation for the evaluate of the expressions. Unfortunately, it leverages a compiler, which can sometimes produce errors or incorrect answers. Now, to summarize everything up, and we believe that this is going to be a great initiative that's going to enable so much stuff, but to summarize up everything that is going to be enabled from the debugging standpoint, we're going to achieve 100% accuracy in the code locations, meaning that we'll be more certain when we showcase where we are in your source code. We'll be able to display all the variables that are either on stack, on memory, or anywhere else, and ensure that the constant folder variables are, if there is a way, we would be able to decompose them. On top of that, we'll be able to decode all of the memory of your smart contract, as well as showcase all the storage slots that have been transferred during the transaction. And last but not least, these two things, which are my favorite, is being able to evaluate expression without the need for the compiler and be able to do it on any line number there is. So these are all the great things, but we believe that the impact of implementation of the debug format is going to go even beyond that. We believe that it's going to be a tremendous new step for the whole ecosystem. Why we think that? Well, it's pretty obvious. The first thing is this is going to accelerate development cycles a lot, which is going to result in more applications going to the production, and in the end, more users onboarding to the blockchain ecosystem. We're going to have higher quality and the better security of the smart contracts. We all saw from the beginning, and we all know how many hacks occurred on the Ethereum blockchain. It's a numerous amount of millions of dollars who are going to the attackers every year. We think that with better debuggers, with better tooling, we can prevent this. a thing that might not be clear from the beginning, but with this, we believe that there's going to be a better interoperability between tooling and between platforms of the Ethereum ecosystem. So essentially, what we see is going to happen is that it's going to be possible to integrate with so many other tools in the ecosystem, similar to how it is now in the Web 2. And of course, one of the biggest things that's going to come out from this is we all know how important it is for the newcomers to be able to onboard to the technology, have an easy time learning things, etc. We believe that with this format, we're going to be able to push the tooling to the same level that is right now in the Web 2.0 space. And all of this combined, we believe is going to bring a broader adoption to the Ethereum ecosystem, which we all here very much want. And to wrap things up, as mentioned, this format is still in the draft phase. If you have some ideas or you want to contribute, feel free to go to the ethdebug.github.io/format. We assemble every other week, and we'll definitely go over all the ideas that were presented. Or if you have some other idea, feel free to come talk to anyone from Tenderly, and we'll definitely share these ideas with the rest of the folks who are working on this format. And I think that's it. Thank you. Are there any questions, maybe? Yeah, sure. Let me just repeat the question. So you asked, you said that in the Java, for example, you're able to stop at any breakpoint and then modify the code. Yes, we'll definitely be able to do that. Most likely, we'll need to leverage the compiler for that. So we won't be able to do it out of the box, simply because there's additional steps in changing the source code and then running those instructions. But we'll be able to do it nonetheless using the compiler. And great question, thank you.
Hello. I might have some. I might have forgotten something, but is your debugger is online only?
Yes, it's online and you can use it, but it's not the default path of the compiling of your smart contracts. So right now it's going through the assembly and then directly to the EVM bytecode. In the future, Solidity team plans on making it the default way of compiling. Right now, you have to wait somewhere around anywhere between 10 seconds and 10 minutes for your smart contract to compile, which is not the case with the legacy way of compiling. But once the UL compiling reaches a certain level of maturity and performance, Solidity team plans on making it the default way.
My question was actually more about, code privacy, because it's hard to debug. If we, for example, don't want to share the code with anyone, we can't use your debugger, right?
Sorry, can you repeat the question?
If we are a bit trustless and don't want to share the code with Tenderly, we can't use your debugger because it's online only.
That's a great question. Yes, currently the Tenderly debugger only works on our dashboard. In the future, once we see the level of quality of the debugger reaching certain degrees, we definitely do plan on making it open source.
Yeah, thank you.
Okay, thank you so much.